Hi all. Algebra is a branch of mathematics which deals with constants, variables, curves and so on. Today let us take a topic, polynomial, from the branch of mathematics, algebra. In our previous classes already we learned the basic concepts related with polynomials like value of the polynomial, zero of the polynomial, the standard form for the polynomial and classification of the polynomials based on the degree, factorization of the polynomials and so on. But let us have a quick review of all those topics what we learned. First, let us begin with the polynomial word itself. Polynomial means many terms. Poly means many and nomials in this case means terms. What is a polynomial? It is an algebraic expression combined using the operation symbols, the terms, constants and all. So here we can check what is the standard form for the polynomial. The polynomial with variable x is denoted as p of x equals an x to the power n plus an minus 1 x to the power n minus 1 plus etc. plus a naught. What is a naught, a1, a2 etc. up to an? They are nothing but the coefficient of each term, and the coefficients are the real numbers. Here we could see the variable it is x. We can create the polynomials with the different variables y, z and so on. If I am using a variable y, we can denote that particular polynomial as f of y. Now we can have the next topic, it is degree of the polynomial. Degree of a polynomial is the maximum exponent of a polynomial. Please take your course book along with you right now, and we can mark the important points of the chapter, and the important points are highlighted on the screen. You can have a look for that one. So please, I'm just going to read all those points now for you. The very first point for you, if p of x is a polynomial in x, the highest power of x in p of x is called the degree of the polynomial. For example, 4x plus 2 is a polynomial in the variable x of degree 1. 2y square minus 3y plus 4 is a polynomial in the variable y of degree 2. So what we are checking here is, we are checking the variable term in each polynomial and we are checking the maximum exponent of that variable in that particular polynomial. The maximum exponent turns to be the degree for you. Now, based on the degree, we can classify the polynomials. Which are they? Linear polynomial, quadratic polynomial, cubic polynomial, biquadratic and so on. So we can begin from the very first one. It is linear polynomial. What is a linear polynomial? Linear polynomial is a polynomial of degree 1. So we can mark the points related with that one. Here it is given in the course book for you. A polynomial of degree 1 is called a linear polynomial, and for example, the examples are given in the course book for you. 2x plus 3, where x is a variable for you and the exponent of the variable x is 1. So we can say that 2x plus 3 is a linear polynomial. So is it possible to have that linear polynomial with a single y itself? Of course, it is a polynomial because only our concern about the exponent, that should be 1. Now we can move to the next one. It is a quadratic polynomial for you. Quadratic polynomial, what does it mean? Quadratic, the word, it is derived from quadrate. Quadrate means it is square. So a quadratic polynomial is a polynomial of degree 2. So we can have examples of that one like y square plus 2y plus 3 and x square minus 2 and so on. So here we can mark the important points related with the quadratic polynomial. A polynomial of degree 2 is called a quadratic polynomial, and the name it is derived from that quadrate already as I explained to you, and the examples are also given in that one. You can have a look for that. And in the screen also it is highlighted, so we can check for that one also. Now the next one, it is the turn for our cubic polynomial. So of course, first one it is the degree 1 linear, second one quadratic, it is degree 2, and now it is the turn for cubic. And already we are familiar with the cube of a number. Cube of a number means if it is a number 3, the cube means it is represented by 3 to the power 3. So of course cubic polynomial means the polynomial with a degree 3. So here it is, the points are given for you in the course book. It is a polynomial of degree 3 is called a cubic polynomial, and the examples are also given in the. We can have the next topic, the standard form for the polynomials. Already we discussed what is linear polynomial, quadratic, cubic, and the examples for each. So what it comes, the standard form. For the linear polynomial, the standard form it is ax plus b, where a and b are the real numbers and a not equal to 0. We can give an example for that one, x plus 5. X plus 5, if I am checking the variable, it is x in that polynomial and the exponent of x is 1. So it is a linear polynomial for you. Now I have a doubt for that one. Shall I give that a equal to 0 since a and b are the real numbers? Of course, the real number means it is a number system. It comes under the whole. So if I am giving the value for a 0, what will happen for that particular example? 0x plus 5. If it is 0 into x means what is the answer for you? X. 0 into x means it is 0. So we are having only 5 in that polynomial. What is 5? 5 is a constant polynomial. What about the degree for that one? 5 can be expressed as 5 into x to the power 0. Already we learned the laws of exponent. Any x to the power 0 or a to the power 0, any number raised to the power 0 gives you 1. Now we can move to the next one. It is quadratic. Quadratic means, as we know, the degree is 2. So how we can frame the quadratic standard form? So here we are introducing like ax square plus bx plus c. Here also, of course, a, b, c are the real numbers and the condition should be given a not equal to 0. For example, here we are having 5x square plus 7x plus 3. So here the coefficient of x square, the leading term, it is 5. If I am giving that value of 5 in place of that one 0, that term 0x square turns to be 0 and we are getting a linear over there. So the condition is compulsory. It is mandatory to put a not equal to 0 for the standard form for the quadratic. Now it is the turn for the cubic polynomial. The cubic means, of course, the degree is true. The degree is 3. So how it comes? Ax to the power 3 plus bx square plus cx plus d, where a, b, c and d are the real numbers and a not equal to 0. We can have the example for that one. It is 2x to the power 3 minus 4x square plus 5x minus 4. Here also, if I am checking the leading term, it is 2x to the power 3. In that one, the coefficient is a non-zero number 2. We can check all these 4 terms should be there in the cubic. I have a doubt for that. So we can have a look for another examples for the cubic. I can put simply x to the power 3. Still it is a cubic polynomial. Our concern for the maximum exponent of the variable, it should be 3. That's it. Now we can move to the next one, biquadratic. Biquadratic means it is degree 4. So how about the standard form? Already we are having the linear ax plus b. From that one to the quadratic, ax square. Then next one, ax to the power 3. Of course, it should be ax to the power 4. So we are having one more constant over here, that is e. Ax square plus, if I am doing ax to the power 4 plus bx to the power 3 plus cx to the power 2 plus dx plus e. We are giving the descending order of the exponent over here to express the terms in an order. So here also, as you know, that a, b, c, d and e are the real numbers and a not equal to 0. Here we are giving the example for that one, 7x to the power 4 plus 5x to the power 3 plus 3x to the power 2 plus 6x plus 9. We can create our own examples for that one. Only the thing we should remember that the power of the leading term, the variable should be, the exponent should be 4 if it is biquadratic, it should be 3 if it is cubic, and it should be 2 if it is quadratic, and for the linear, of course, it is degree 1. And value of the polynomial. So what is meant by value of a polynomial? So we are going to talk about a polynomial p of x with the variable x, and I just want to check what is the value of that particular polynomial at x equal to 2. For example, if I am checking a variable with x and the polynomial p of x, it is 2x plus 5 over there, and I am giving the value of x as 2. So it will turn as P of 2 equal to 2 into 2 plus 5. What is 2 to 0? 4. 4 plus 5, 9. That is how we are getting that value. Whatever given variable for you, we have to replace that value by the variable we have to replace by the value given for you. If x is given as 2, I have to replace by 2. If in place of that x equal to 2, if another question, if it is x equal to minus 1 means, I have to replace that variable x by minus 1 and so on. Now, there is one more concept it comes in the sense of that along with the value of the polynomial, together it comes. If the value of the polynomial turns to be 0, because there is a chance to get 0 also. If I am getting 0 in that sense, I can say that x equal to 2 or x equal to that particular number, it is the 0 of the polynomial. So, two concepts together we are having. Value of the polynomial means at x equal to a, if I am going to find out the value means, I have to replace in the given polynomial the variable wherever it comes, I have to replace by a. And if it p of a turns to be 0, we can say that it is the 0 of the given polynomial. Now in detail we can study what is 0 of a polynomial. So first one, linear polynomial. As we know that linear polynomial, the standard form, it is ax plus b. So the step 1 for you, we have to equate that p of x equal to ax plus b with 0. So then I have to solve for x. We can have an illustration for that particular one. P of x, it is equal to 2x plus 3. So what is the very first step? We have to equate that polynomial p of x with 0. That means we are going to solve an equation p of x equal to 0. So p of x means nothing but it is given for you 2x plus 3. So I am just going to equate 2x plus 3 with 0. And already we are familiar with in smaller classes we used to solve the linear equation we did for grade 9 and in our grade 8 also we know how to solve an equation by transposing. So the first step means what we have to do, we have to keep the variable on the left hand side itself and move the other leftover term to the right hand side. If I am moving the term to the right hand side, definitely the sign changes. Here it is 2x plus 3 equal to 0. What is the first step for you? 2x I have to keep on the left hand side and transposing plus 3 to the right hand side. So it turns to be the plus 3 on left side. It moves to the right. It turns to be minus 3. So I am getting 2x equal to minus 3. Now the left hand side I am having 2 multiplied by x. So if I am transposing that multiplication to the right hand side, it turns to be division. So x equal to minus 3 divided by 2. So we are getting x equal to minus 3 by 2 as the 0 of the given polynomial. If you want to verify whether I got the correct answer, what can be done? We have to replace the value of x by minus 3 by 2 in the given polynomial and we can check whether the answer turns to be 0 or not. Of course, there is no doubt for you. Definitely you will get 0 on the right hand side.
Okay.
So we can mark the points that already we discussed now, which are the value of the polynomial and 0 of the polynomial in your course book. Okay. So the highlights will be there on the screen, that also you can have a look for that. Okay. So I'm just going to read all those points for you now. If p of x is a polynomial in x and if k is any real number, then the value obtained by replacing x in p of x is called the value of p of x at x equal to k and is denoted by p of k. And here the example also given for you. The p of x, it is given as a quadratic x square minus 3x minus 4 and the value at x equal to minus 1 we are going to find out. So of course I have to replace that value of x by minus 1 and we are going to find out p of minus 1. So p of minus 1, if I am checking, I am getting that answer as 0. So one more concept it comes there, that value x equal to minus 1 is the 0 of the given polynomial x square minus 3x minus 4. Okay, now the next one, it is here it is given. A real number k is said to be the 0 of the polynomial p of x if, what is the condition? We are replacing x by k. The value should be equal to 0. That means the p of k equal to 0. Now I can find out the 0 of the linear polynomial now. How? P of x, what is the linear polynomial? Ax plus b. Now we are going to equate that ax plus b with the 0. So what is the value of x from that one? We can solve that particular equation. ax equal to minus b and x equals minus b by a. So we can have the comparison of that minus b by a with the general form given for you, the standard form ax plus b. What is a and what is b? B means it is the coefficient, b means it is the constant term, and what is a? A means it is the coefficient of x. So we are getting one more relationship connecting the 0 with the coefficient. What is that? We can mark that point. The 0 of the linear polynomial ax plus b is minus b by a. It is equal to minus constant term divided by the coefficient of x. So these are the things related with the linear polynomial. We can move to the next one, quadratic polynomial. So here we can, the very first one means I have to start from the standard form, of course. And I hope you are now familiar with the standard form for the quadratic. What is it? It is ax square plus bx plus c. So here we are going to check how we can get the zeros in the case of quadratic. Since the quadratic means the degree is 2, definitely 2 zeros should be there. But how we can get that zeros? So the steps involved in that one we are having. Express the given polynomial, the first step for you in standard form. Sometimes it will be given for you like a x square minus 7 plus 3x. In that sense, I have to rearrange the terms according to the descending order of the degree. So here it is for you, f of x equal to ax square plus bx plus c. Now what is the second step? We have to factorize the given polynomial using any one of the standard identities. Already we are familiar with so many identities. Basically we need the standard identities, 4 standard identities which are there. From grade 8 onwards we know the standard identities. So we can have which are the identities. The first identity for you, it is a plus b the whole square, it is equal to a square plus 2ab plus b square. Then what is the second identity? It is, we have to change the sign, plus or minus. It will come a minus b the whole square equals a square minus 2ab plus b square. And the third one, it is a plus b into a minus b, it is equal to a square minus b square. And the fourth one for you, x plus a into x plus b equal to x square plus a plus b into x plus ab. So we have to check whether the given polynomial it is in the form of which identity. The first step, we have to identify the format of that particular polynomial, have a comparison between the given identity for you, and then we can recognize by which format we have to move and which identity can be used to factorize that particular one. If I am doing the factorization means, definitely I am going to get a linear factors over there. Once we got the linear factors, what we had to do? We had to equate each linear factor with a 0. And then we are getting the zeros of the particular polynomial. And for that linear means I got only 1 0 over there. I can represent it using that. Normally we are having the variable x means I am just using x equal to 2 according to the situation. So there also we can introduce one more new term over there because we are in grade 10 and already we are up to grade 9 we are using that variable x, y, z and so on. So there should be some changes for you, isn't it? So we are introducing the Greek letters in place of that x and y and z. Here I can give the variable alpha if it is only 1 0 there. But here means quadratic, 2 zeros are there means it is not sufficient for you. We need one more 0. So I am just denoting it as beta. Oh my god, if I am thinking about that cubic polynomial means definitely 3 zeros should be there and one more letter I need. So here it comes the role of gamma for you.